Thank you for the introduction. Good afternoon, everyone. I hope that you are well rested after the short coffee break that we had. So today I'm very honored to share with you a projection of the future of electric vehicle charging, also known as EVSE. So Greenlots was founded a few years ago in Singapore, and we moved, we had a new office in California, in San Francisco and Los Angeles, where we contributed to the growing electric vehicle markets there. So we are one of the main operators of DC fast charging infrastructure in North America. And in addition to that, in Singapore, where I'm from, we have the largest AC public charging network that serves a small group of customers that are driving electric vehicles. So today, I will start my presentation to share with you a bit about the industry perspective of how this very young industry is evolving and what are the state of things right now. So before I start, I just want to thank Mr. Yuren for a very wonderful presentation. I was just sharing with him just now that if we could have done this presentation together on the same stage because we are singing the same tune. So I would like to provide a complementary perspective to what was shared just now by Mr. Yuren. And I would elaborate a bit more about how utility companies will play a big part in this growing industry. So, from a different source, Mr. Yuren took his information from the Bloomberg New Energy Finance. I have some slides from that too, but for this slide, it is actually from the Global EV Outlook for 2016. The version for 2017 is not out yet, but the picture is very clear. We are seeing the start of an S-curve where technology replacement occurs. So you might be familiar with the S-curve whereby there is exponential growth at the start and in the middle of it, and eventually when it becomes mass market, it starts to slow down. So what we have here is that electric vehicle sales are taking off exponentially over the past few years. And this is the projection for which beyond the 2016 onwards, we are going to see this sustained exponential growth whereby we are going into millions of vehicles. This chart shows the cumulative number of electric vehicles on the road. So the slide that was shared just now is not directly related to this, but you can see over here in dark green the growth that is occurring over time. Every year it gets a bit higher and higher. But in the background, the lighter green color shows the cumulative numbers that are growing. And by 2040, the electric vehicle sales would account for about 1/3 of all all vehicle sales. So this is a very huge industry and a lot of market potential. So here is my slide from Bloomberg New Energy Finance, one of my preferred sources of information as well. I wouldn't say that over the past few years the lithium-ion technology has been improving very quickly, and one important component that has been holding the sales of EV back is the price. So now, as the battery plays a big part of the cost component, as the cost of batteries start to come down quickly, we would be seeing a corresponding drop in the price of electric vehicles as well. So we can see over the past 5 years, 77% drop in the average battery pack price. This is something that we have been very familiar with when we talk about, for example, solar PV. The price of solar PV experienced the same drop, and subsequently the sales, or rather the installations of solar PV went up exponentially. So the relationship is very clear. Now, on the chart on the right side, you can see that China, over the past few years, they quickly leapfrogged into second or first position on, above US and Japan. So right now, China is a major player in this sales of electric vehicles. And this is, of course, going to grow over the next few years. And what we have here is more recent news development in Thailand, whereby we have the announcement of automakers who are coming in to establish manufacturing plants to provide provide assembly for PHEV vehicles, PHEVs, or even battery vehicles. So this BMW Group Manufacturing Thailand set aside 1 billion baht for 2016 and 17 to upgrade their existing operations to accommodate the new assembly line. So this is the industry, this is a very clear statement from the industry that PHEV is going to be a strong growth sector for Thailand. So to summarize, as of December last year, there are more than 2 million plug-in EVs and over 60 models of plug-in EVs across the world. Now, plug-in, the 60 models are important as we can see in the cell phone or the smartphone evolution, whereby at the early stage, there are only a few models that were available. You only can purchase a certain size of smartphone, certain battery life, and certain operating system. But as more players come into the picture, more industry players come into the picture, they start to provide different variations of the smartphone. You start to have the tablet, you start to have a phone and a tablet known as the phablet. You have the slightly bigger size smartphones. So all of this provide one thing to the customer, which is the power of choice. And with more choice, because customers are able to find something that suits their needs more directly. So as we have more models of electric vehicles, maybe some drivers prefer to have a SUV type big car size, or some prefer to have a smaller electric vehicle. So when there are more models available on the market, it is easier for them to make the transition towards electric. Now, I'm sure Mr. Yeren has explained this quite clearly, that China overtook the US to now become the biggest player for electric vehicles. And in fact, China, with its 650,000 vehicles, they are more than the rest of the world combined. Rest of the world referring to the other countries outside of Europe, Japan, US. So we have heard from the battery industry, or rather we have heard from the industry experts that the EV battery prices are falling and they will continue to fall over the next few years. And within a short time, maybe within a decade, it would even become cost competitive with the normal internal combustion engine, which is right now, of course, the majority vehicle on the road. So one key factor for the popularity of EVs is, of course, the charging network. So a reliable and extensive charging network, which is made up of many individual charging stations known as EVSE, is critical to the growth of electric vehicle industry. So now I'm going to move on to the second part of the second point of my presentation. But before that, I will just explain a bit more about Greenlots. So Greenlots is a young company, and our mission is very clear, that we want to make EV charging as simple and as straightforward as possible. So how do we do it? We adopt open standards, which I will explain a bit more later. Open standards is one of our core philosophy in terms of integration. We believe that it's not going to work when one company comes in with all the solutions, but rather one company provides the tools necessary for integration. And when we have more and more integration that is amongst the different companies, then that's when we have an ecosystem. All right, so open standards is one of our core principles. And then we also provide the network management tools for building owners, for property owners to manage their charging stations. And this allows them to take care of the billing, the payment, the energy reporting, and also the smart charging and demand response. And thirdly, we are customer-centric. That means we work closely with the EV drivers as well, because they are the main audience. They are the main target audience. So we make it easy for them to make payments, to link their credit card, mobile app, and also to, in future, we are going to look at roaming as well, because roaming will become a very important part of EV charging. So to sum up, Greenlots is actually a hardware agnostic company. That means that we do not depend on, we are able to work with many different hardware manufacturers like ABB. And then our solution has been deployed extensively in many countries across hundreds of units. And we believe in a turnkey solution whereby we get involved right from the start of the project, whereby we conduct site surveys, we take care of installation, and after the installation and commissioning, we will take care of the operation as well. And that is where you have the customer support. Because if you look at the EV customers, they are actually the best advertisers for the industry. The first adopters will be the ones who are telling their families, their friends about their electric vehicle, and they are proud to show off to them about the capability or how convenient it is to charge. Okay, so now going back to the ecosystem. I would just spend some time on talking about ecosystem because I think this is quite important. So as we know, ecosystem exists in everywhere. So in nature, when we talk about a natural habitat, there are several key species that will play very important roles within a habitat. And each one of these species actually depend on each other. They require to coexist with each other in order for the habitat to thrive. So if there is any one species that is removed from ecosystem, it actually weakens the ecosystem. And the ecosystem will not be able to grow or even, it might be not able to thrive as before. So when we talk about e-mobility, actually, there is an ecosystem perspective of this industry, whereby we have to grow the industry by involving all the major players, starting with, of course, the automakers who bring the cars in, and then we have to bring in the EV drivers. These are the users of the system. We have the building owners. The building owners are the ones who provide the location, and they are usually the ones who have the charging station installed at their facility. So the building owners are an important part of this ecosystem. Next, of course, is the utility and grid operators, which is EGAT and the other operators as well in Thailand. And lastly, but not least, the hardware OEMs like ABB. So hardware OEMs are I think Mr. Yeren has explained very clearly and very elaborately about how they can play a part in this ecosystem. So, of course, now this presentation is about green lots, so I'm going to put green lots right in the center instead. Okay, so green lots, as we believe in an integrated ecosystem, we see ourselves in the middle of everything that's happening. So we enable technologies, or we enable stakeholders to communicate with each other, to interact with each other. And that is how we believe that this is the right way to grow the industry. So I'm just going to spend a bit of time talking about e-mobility for utilities, because as we know, this is EGAT is a generating authority of Thailand, and electricity is your lifeblood, is your business. Now, e-mobility brings a set of challenges that is quite unique, not seen in other industries, whereby there is a huge consumption of electricity, a small amount of time. Of course, we have the BMW i3 battery, which is upgraded. In 2016-17 version, they upgraded from a 18 kilowatt-hour battery to a 33 kilowatt-hour battery. Exactly in line with what Mr. Yeren mentioned, that batteries are becoming bigger. They are going to consume more electricity. So to put things into perspective, if we look at the battery of BMW i3, 33 kilowatt is probably the same or more than 5 households in Thailand. So this is the 5 households' daily consumption of electricity. That is a huge amount of energy. And we are just talking about one single electric vehicle. Of course, you have the ABB charger right behind it to provide the fast charging that's required. But the key challenge for this industry is really that unregulated EV charging can actually destabilize or overload the network, the distribution network. And this is a problem that we preempted. Eventually, it's going to happen sometime down the road. We have to future-proof the system to accommodate for this sort of challenges down the road. Now, talking about the challenges, of course, is one side of the equation. The other side of the equation is the opportunity that comes with this e-mobility. Now, because we are providing electricity, the customers are going to require to pay for EV charging. And this presents itself as an opportunity for revenue. There is also the ability to do smart charging and demand response, whereby we use a pricing method to change user behavior so that the user will consume energy in a grid-friendly way and not consume energy as and when they require. For example, charging during the night can be encouraged by having a lower price in energy, and this makes it easier for the end user to use energy when the load is, the overall demand of energy is low. And on the other side, when the energy grid is overloaded, you can actually increase the price, time of use, and reduce the overall demand for EV charging during the peak period. And this will bring down the occurrence of network congestion on your electrical system. And of course, moving forward, when we see the exponential growth of EVs in the market, all these electric vehicles are moving mobile batteries. And mobile batteries, they provide opportunity for future grid stabilization. It can be used as a buffer, energy storage buffer. And that's when we can talk about things like vehicle to grid integration. When you have a certain amount of cars on the road and you are able to aggregate these resources effectively, you can use them as an energy storage device or energy storage asset. So we can see across the world, many utilities are starting to pay attention to this. It is actually a natural extension of the utility business and utility and grid operator business, because EV charging provides a form of return, provides a form of ROI. So you can get a bit of revenue payback for your infrastructure. Now, with more than 2 million electric vehicles on the road, the utility companies globally are paying close attention to the sales of EVs. And the Greenlots approach of using open standards with smart charging systems will ensure that we can maximize the potential, maximize the opportunity while minimizing the challenges. Here are some of the utility partners that we have worked very closely with in the United States, in Canada, in North America, United States and North America, and also in the regional markets as well. Now, we are going to the third point. We are going to do a case study on Ecotality. So I'm not sure if you have heard before, Ecotality was actually a company that was set up a few years ago. And their company provides a very good learning point for our industry. So this lesson would be basically it's a good lesson for the importance of open standards in our industry. So at the beginning, in 2006, 2007, when the industry was just growing in the US, Ecotality was one of the big players, and they provided EV charging for parts of US. And as you know, US started into this EV game very early. They had one of the highest number of EVs on the road for a few years running, which eventually was, of course, overtaken by China recently. But Ecotality was a major player in this game. So this company was vertically integrated, which means that they did everything. They have the manufacturing of the EVSE hardware, they have the back-end system, they have the operations, they have the support, everything. So you might be thinking, wow, this company is quite secure, right? So in 2009, under the American Recovery and Reinvestment Act, the US Department of Energy awarded $99.9 million to this company to deploy charging stations across the US. Okay, so the intention was very good because it was after the Lehman Brothers collapse. The economy wasn't doing very well. There were a lot of uncertainty in the market. So the federal government wanted to spur clean tech investment. And they did this by providing grants to companies like Ecotality to develop the infrastructure. Okay. The good thing is that most of the grants went into EV charging installation with both AC and DC, so they covered both grounds. Here are some of the pictures for the charging stations. You can see over here is the AC charger, and over on the right-hand side, you have the much bigger DC fast charging. So very, very impressive, look very nice, and looks very expensive as well. Right, so in total, there was 12,500 AC chargers and more than 100 DC fast chargers installed across the US. And all of these were supported by a dedicated back-end server. Unfortunately, due to some problems in the management, we're not sure what happened exactly, but it's unfortunate that the company did not manage to make it. They had to file for bankruptcy protection in 2013 and were eventually purchased by another group for only 3.3 million. So we can see almost $100 million funding being reduced to 3.3 million valuation. It's a big waste. So we are not here today to criticize, how their management strategy didn't work out. We are here to learn from the important lesson from this episode that we want to prevent stranded assets. So what happened with Ecotality was that their charging stations were only able to work with a single back end. That means that when anything happens to the back end or anything happens to the company, more than 13,000 installed chargers that were already on the field, they were all deployed outside, will not be useful without the back end. And when you have something that is already installed in the field, it is very difficult to do configuration, to do installation, to do the changing of the firmware. And the remaining value of the EVSE was very low because of the inflexibility. And it also because it couldn't work with other backends as well. Of course, there are some other hardware issues, which I will not go too much into detail. If you want to find out more, you can just do a quick research on your part. But the key lesson here is that if the EVSE was OCPP compliant, it might have been a different story. It might have been easier to integrate with other EV charging networks, and it would not risk having so much investment gone to waste. Okay, so as we can see now in the market, it's not just the electric vehicles that have come in different shapes and sizes. Even the charging stations also come in different shapes and sizes. So, of course, the biggest one here is right at the corner. ABB charger is the tallest, right? So it's an advertisement for ABB as well. So charging stations come in various charging power. You have AC and DC charging. And the important thing about all these chargers here is that they are OCPP compliant. This means that they are able to work with the back end that is OCPP compliant. And with that, you are able to bring in a lot of functionality without additional development. You don't have to rewrite the whole firmware. You don't have to rewrite the whole back end system to integrate these charging stations. Okay, so now I'll move. The halfway point of my presentation is done. I will move now into the EVSE present and future. What are the user demands on EVSE? So users today, what do they think before they purchase before they sign up as a member of an EV charging network? Of course, they need to know that the charging is easy, must be user-friendly, must be easily located and navigated to, must be able to work reliably, fast charging, very good, and must be able to make payment conveniently, and most importantly, must be installed everywhere so they can access it, right? These are the user expectations. So in order to convince people to purchase an electric vehicle, you have to first provide this. So now, we look at the process of how Greenlots is helping the end user before he charges his EV. So the installed hardware through OCPP is able to communicate with a back-end server, which is Greenlots, providing real-time information, available BZ fault, the price of charging, the location of charging as well, and then the telematic system, the telematic integration with the automakers would result in the information being displayed on the EVSE, on the EV telematics. So this is something that I will share in the next slide. And of course, the dashboard display will relay the information to the end user so that they know where exactly is the charger if they need to, if they run out of range, how much range do they have to reach that charging station. And of course, thinking ahead, we would also have to have an EVSE reservation system, which is very complicated subject. I think this requires a presentation on its own. But Greenlots is, our role at Greenlots is to make EV charging as simple as possible. And this is a problem that we expect, this is a feature that we expect to be more common next time. Okay, this is an example of the integration that we have done. In this case, with BMW telematic system, the charging information appears on the car so that they will know how to drive, the navigation, and all that. In addition to that, the payment side, we will take care of the credit card integration to know the progress of charging, to receive notification upon any changes in the charging state. And lastly, it is Greenlots operating on a prepaid system, which we believe that would be the most equitable value for money method moving forward. And that's why users will only pay for how much they use. There is no ongoing subscription fee, there's no membership fee. It is just when you need to use, then you pay. Right, so what happens after charging? User, the car is actually consuming electricity from the building owners. Right, so there's a consumption taking place. The users will pay for this EV charging through the Greenlots mobile app. Now, this part would be the reimbursement for the building owners because they just provided the parking space. They are not going to subsidize the energy consumption. Ultimately, the user would have to pay for how much energy they use. And also, the utility will get a small return on investment from the EV charging fee that is imposed. And thinking ahead, when we think about the smart grid, when we think about the two-way communication between the grid and the user, we have to look at time of use and demand response. These features must be enabled in order for this industry to be sustainable. If not, it's going to be a lot of unregulated charging, and that would be quite damaging to the infrastructure if it's not managed properly. So what do users expect in future for EVSE? Instead of user-friendly, it must actually be grid-friendly. The charging stations must be controlled easily controlled by a grid operator. That means you can send pricing signals, you can adjust your rate of charging so that you don't continue to consume energy at a fast charging rate. It must be able to work with different networks or different operators and charge EVs cost effectively. It must be convenient to save money, and of course it must still be installed everywhere. Right, so the McKinsey and Company, it's a research consulting firm. They did a very good report that was recently published on automotive industry megatrends. So megatrends refer to the very strong tide of change that is going to come for the automotive sector. So I think this was covered just now. Autonomous vehicles are going to be more common. The cars are going to have more intelligence to be able to do self-driving or some sort of driverless feature. Cars are going to be more shared in future. That means the private car ownership model that has been working so far might be changed, because if you look at the traffic situation, many parts of the world, including Bangkok, many parts of developed countries, they are having a lot of smog, pollution, congestion, problems that are associated with having too many vehicles on the road. So sharing, car sharing, vehicle sharing concepts become more appealing in these situations. Electrification. The cars are not only having electric motors, but they are getting bigger batteries. The battery size is always big. The appetite for energy is always increasing. Okay, and of course with lower battery cost, you start to have better range for your EVs as well. And lastly, you would have a connected electric vehicle that is always connected. It is always on the cloud. It is always getting information or sending information no matter where you are. So these four trends, these four electric mobility trends would likely guide the way for the industry. And how does EVSE, how is EVSE going to be affected by this? Of course, EVSE will always follow the trends of the EV, because EVSE is the charger for the cars, right? So what is going to happen for each one of this scenario? Autonomous driving would mean that EV chargers of the future would be required to incorporate some elements of wireless charging. Right now, the present state of technology is still very expensive, because you have to do excavation, some trenching works to be able to incorporate those the induction charging mechanism must be embedded in the floor. But technology is always improving, so in future we might see a cost reduction in wireless charging, and that will become more common and more convenient for users to charge their cars. Shared vehicles would mean that you will need to have a social element to charging the vehicles as well. For example, if you are sharing your charger with your neighbor and you come back with an electric vehicle and you are at 10%, whereas you see your neighbor has been parked there overnight and there's an empty lot right beside. So there should be a way of communicating with another user on sharing the charging station. Why don't he be able to unlock his plug so that I can take it and plug into my car? Right, so this is an example of social charging. Bigger batteries, it was covered quite a bit in the previous slide. Bigger batteries would mean that you need higher charging power. But higher charging power would mean difficulties for the grid integration. So we need to have smarter and higher power, higher charging power. And lastly, connected would mean that eventually the grid, the electric vehicle is an important part of the smart grid. So it should have it should be future-proof to be able to function like a smart grid component. This is the green lots architecture, whereby we implement a smart energy system using open standards, for example, OCPP and Open ADR. Open ADR stands for Open Aggregated Demand Response. So this is one of the tools that utility operators like to use when they want to manage EV charging. So now, I'm going to go to the most interesting part of the presentation on the EVSE deployment phases. So these are just some of my observations from industry developments that happen across different countries. The technology does not come in overnight. The replacement is actually very slow and gradual. Slow, but the effect is cumulative. So I'm going to talk about it in 4 distinct stages. So in the first phase, there's the government support. So in this part, of course, as you can see, the government needs to take a very central role in guiding the policies, guiding the funding that goes into promoting this industry. And then the second phase is the PHEV majority market, which, as you know, plug-in hybrids would be the stepping stone for full electric cars to come. The third phase is the EVSE. The EVSE needs to be grid interactive. What does grid interactive mean? It means that it is able to have a two-way communication with the grid, to be able to control by the grid, to be able to feedback to the grid. And last of all is, of course, the battery EV majority market, BEV majority. All right. So in each of these 4 different phases, we will have a look at the 6 different variables that we will monitor. So variable number one is, of course, the number of EV charging stations. Number 2 is the number of plug-in hybrids on the road. So plug-in hybrid, as you know, they can run on both petrol and electric. So they can survive without electric charging actually. You can run them like a normal hybrid vehicle. Now, battery electric vehicle, on the other hand, is not able to do that. They are fully electric. You don't have any petrol backup. So they will be very dependent on the EVSE. Okay, the 4th variable is the charging revenue. How much you are earning from public charging or residential charging or workplace charging. Okay. Number 5 is the amount of grid interaction that the EV charger has. So the ability for the charging station to communicate with the backend, to communicate with the grid, to respond in terms of pricing changes, in terms of network congestion. And the 6th and the most important, probably to you and to everyone actually, is the overall grid impact, because we do not want to bring in electric vehicles at the risk of damaging or overloading the electrical grid. So we have to be preemptive of the impact of electric vehicles on the electrical grid. So when there is more EVSE to grid interaction, generally there will be less grid impact because it is two-way communication. Okay. So now we look at the first phase, right? So there's a lot of strong incentive from the government to do two things. One is to promote EV sales, and the other one is to develop the EVSE infrastructure. So you're providing the cars, you're making it easy for people to buy the cars, and you're putting charging stations around. So this will be catered to the early market and the early adopters. Okay, these are some of the, I'm using very broad term, low, very low, negligible, right? Because this is a very early market. So I'm going to use them, I'm going to use a chart to show the deployment phase. So I will represent them as icons. Each one of these variables will have a different icon. Okay. And of course, the grid impact is in red. This is the transmission tower. It's in red, means bad. Okay, so in the first phase, it's like this, very simple, all at the bottom. Okay, now in the second phase, as we know, plug-in hybrids are actually able to function without the need of charging. So the sale of plug-in hybrids would not be so much constrained by the development of the charging network. And when commercial buildings start to have more EV charging on their premises, the government does not have to play such a crucial role of trying to put charging stations out at different places, because the market starts to take over. And they see the value of having customers coming to their premises to use their shopping center or to use their facility. This is also known as destination charging. It is employed very famously by Tesla, where they install charging stations at places where people want to spend a few hours at. Okay, so the charging station brings in something called the retail footfalls. Retail footfalls is a benchmark in the property sector where the human traffic is increased because of the charging station. Right? So this is what the market looked like. These are just some of my projections. Okay, so plug-in hybrids, of course, taking the lead now, right? While the rest of the industry grows at a slower rate. And you can see there's almost no EV charging revenue because there are very few battery electric vehicles for the time being. Now, we move to the third phase, whereby EVs are becoming more common, more awareness. People know what is an EV. More people start to drive EVs, they start to see EVs on the road, they start to see charging stations on the road. But there is a downside to this because you start to have overcrowding of electric vehicle charging station. You have people parked there just to charge maybe one for 20 minutes, and then they can park there for 20 hours. You cannot stop them. So these are some of the problems that we will foresee in this stage. And that's why we have to preempt these problems by having the necessary features to counter them. And on the other, in addition to that, there's also fast charging. When you start to have more vehicles on the road, you start to have more fast charging capability, and they are going to draw a huge amount of power. Remember that in the previous slides, I mentioned that a single EV can actually take up more than 5 household daily consumption of energy. So if there are more EVs on the road, this problem will become more, it's become more extensive problem. So the conclusion is that EV charging during this stage must be smartly regulated. So we can see that the grid problems in red is starting to go up a bit. But of course, the grid interaction, the reason why it goes up a little bit is because the grid interaction criteria is going up faster than it. So still, the plug-in hybrid is still right on top, where its the sales of the plug-in hybrids is not so affected by the number of charging infrastructure. Okay, so now we go to the fourth and final phase. Now, this is we call it the break-even point, whereby EVs become cost competitive with normal cars, and they even become cheaper to operate. So it becomes a very simple economics question. An EV is cheaper than a normal car in terms of capital, in terms of upfront cost, and in terms of operating costs. It is very easy for the consumer to say, yes, I'll purchase an EV. So when this happens, of course, when there's infrastructure that is available, makes it even easier for customers to say, yes, I will choose an electric vehicle instead of a normal car, right? And to add on to that, the battery size, the EV range keeps expanding, and fast charging you don't have a problem with range anymore because fast charging is more conveniently available. So now in this stage, the chart becomes a little different. So you can see that battery electric vehicles are right at the top now, followed by the plug-in hybrid. Of course, I'm not saying that the plug-in hybrid stops growing. It is still growing. It's continuing to grow. But at this point, the battery electric vehicle makes more sense than the plug-in hybrid, largely due to the reason of the falling battery size. The plug-in hybrid's battery keep increasing until at a certain point of time, it's probably like 95%. And then you just add a bit more, you can remove the internal combustion engine altogether, and it becomes a full electric vehicle. So that is of course, the BEV majority phase. And now you can see that the charging revenue suddenly goes up. This is the revenue icon. So it goes up accordingly with the battery electric, because battery electric provides most of the charging revenue for EVSE. And even in this state, the impact on the grid is still low. Why? Because we have managed charging that is providing the functionality, the future-proof functionality for EV chargers. So now, if we put all the points together, we are going to draw the line. You can see a S-curve for the plug-in hybrid. Okay, this is expected for most technologies. So they start off very quickly, and then subsequently, as the cost of the battery starts to come down enough for the battery electric vehicle, the battery electric vehicle starts to take over exponentially, right? So the growth is here. So this is the break-even point. And now the EVSE infrastructure grows linearly. The reason why it's linear is because the front part, phase 1 and phase 2, is supported by government. After that, the government takes a step back and they say, okay, I have invested enough in infrastructure. The market is ready to grow on its own. So that's where the commercial properties, buildings, they start to demand for EV charging at their own premises. And phase 3 and phase 4 will be more of commercial developments. Okay, next we have the charging revenue. This one is also money matters, because EV charging, we are talking about electricity usage. So there must be a form of revenue for the operators. And next would be this icon is the EVSE, the EVSE grid interactive EVSE. So you can see during this phase, the grid interactive EVSE actually has to improve very quickly before the battery electric vehicle becomes a majority. And last of all, when you have this happening, the grid impact is mitigated. It's right at the bottom. So you have a very smooth transition. Now, we are going to look at the items in, we are going to break down the parts into 3 important points. So plug-in hybrids and EVSE growth. So as I mentioned, plug-in hybrids are special because they do not depend on EVSE. They actually grow naturally because that is the most cost-effective and the fuel-efficient way. Right? Next is the EVSE growth. The first phase and the second phase are supported by the government. The third and the fourth phase are supported more by the commercial. So it's a linear growth. How does this impact the electric vehicle? So of course, the electric vehicle, the full electric vehicle benefits the most. And that's how you can see the beginning of the S-curve. And along with the battery electric vehicle, you have the charging revenue that also grows. And the third comparison would be between the grid interaction and the grid impact. So the charging stations must be grid interactive first. They must be future-proof. You cannot do it in the way of eco-tality, whereby you realize that, oh, the charging stations do not have this functionality. We have to retrofit them. It will be very expensive and it would be inefficient to do it this way. So we want to bring the capability, we have to design the capability into the system in the first place. And with that, you can mitigate, you can reduce the impact on the grid. So this final, or this second last slide will show you what happens if grid interactive EVSE is not there without the third phase. So what will happen is that this functionality is not inbuilt, so the grid impact actually grows much faster than what is ideal for the country's development. So this will mean that there's a lot of congestion, unregulated fast charging, unregulated AC charging will all add on to the network congestion issues. And then you start to have a lot of negative you have a negative press about the impact of EVs on the market or on the electrical grid. This will not be good for the growth of the industry. Right? So my last slide, just to recap everything that I mentioned, e-mobility is a huge business potential for utility companies. I think this is really very clear. Open standards are the way to go. Open standards, OCPP, Open ADR, these are some of the standards that would be important. And it is important for companies that come into this industry to be collaborative instead of competitive. The reason why is because when you start to have a closed system, you start to compete with each other, it becomes similar to the eco-tality story, whereby they bring in their own hardware, they bring in their own back-end, and they say, my back-end is the best. And if anything happens to the company, it's not good for the industry. So we want to be a collaborative industry instead of a closed industry, and open standard is the way. And thirdly, EVSEs must be future-proof for emerging trends. And the 4 major trends are bigger batteries, more automation, more connected charging, and you need to be smarter about it. So I've reached the end of my presentation. Thank you for your attention.
Thank you so much, Mr. Terence.